Okay, I will back to remind you what is the triple integral rectangular coordinate. Before I start with triple integral, I start with a one variable function integration, what we call it definite integral from a to b for f of x dx. What is the meaning of this one? The meaning is the area under the curve from a to b. Okay, that's fine. This is the definition of the meaning of the concept of the definite integral from a to b from my function f of x with respect to x. Next, we got the double integral over rectangular area or non-rectangular area. What is the meaning of this one? Yes, when I'm integrating a function of two variables with respect to dx and dy, I will have the volume of this surface defined by this function, okay, in the area bounded by x from 2 and y from 2, right? So the meaning of the double integral of the function f of x is the volume of the surface defined by the function f of xy. Today we will start with the triple integral in rectangular coordinates, I mean x, y, z, or Cartesian coordinate. What is the meaning of this one? We finish with the area and volume. So next, if you multiply the volume by the density, you will have the mass. So it could be the mass, okay? And what is the function in this case? The function will be the density of this type of material, okay? Or sometimes you have moment of inertia. If you call it Iz, this is a moment of inertia about z-axis, okay? So the meaning of the triple integral maybe give me the mass, give me the moment of inertia, okay? Once I have the mass, I can find the centroid. Okay, can I get backward? Yes, if the no function here is 1, this one, it will be integration of the dv, the volume element. So I will get the volume by the triple integral if my function is equal to 1, which is this one. What about if the function is equal to 1 in the double integral? I'm going to integrate dA, the area element, so I will get the area. Okay, what is the function here is equal to 1? I have the distance from A to B. Okay, so I can get backward if my function is equal to 1. But I cannot go forward. We start with this example. I'm going to, yes, my function is 1 in all of these questions, right? But sometimes I start with integrating with respect to y, x, and then y, and by the end, I am integrating with respect to z. But I reverse the order of the integration. Okay, yeah. So I start with y, and then x, and last z. If I go, say, number b, I integrate with respect to x first. What is the integration of x? dx is x from 2 to 0, so 2 minus 0 is 2. Next, I'm integrating with respect to z. What is the integration of 2? With respect to z, dz will be to z. It is 2z, and that, well, the upper bound minus the lower bound. So I got this one. Now you can do this one by the calculator, or you can integrate with respect to y. This 2, you can take it outside. The integration of 1 with respect to y is y. The integration of y with respect to y is y squared over 2, and you substitute from by 1, and then minus the substitution of 0, you will get y. Also, if I start with dy instead of dx and go through the steps, I'll get the same value. If you try the rest of all of this one, you will have the same answer, which is 1. What is the meaning of this one? I said, yes, there is no function here. The function is equal to 1. So this is a volume element. So the result of the triple integral will be the volume. The volume of what? The volume of this shape, which is like edge, right? So all of these formulas, the 6 formulas, give me the same answer, which is the volume of this edge. Yes, this is my surface. Okay. Next, I can find the volume of the region D enclosed by two surfaces, right? Yes. Again, these two surfaces, not two functions. Because as I said, to find the volume, I should have one in front of the volume element. Okay. I start with integrating with respect to Z. Okay. So I know Z from this one and that. So I know the lower bound and the upper bound of the Z. What about Y? This is the shape, right? So exactly like double integral, to get the lower bound of Z and upper bound, you go from down Z to the up, right? To get the boundary of Y, you go from the left to right. For X is the same, right? So this is a Z boundary. This is the Y boundary. This is the X boundary. And I said the last integration boundary must be constant, as you see here for X. Yes, I go through this one. I got the answer. Yeah. This is give me the volume of this surface, right? So if you fill this surface by any kind of liquid, you will get this amount of the liquid, right? We got some question here. We tried using MATLAB, so you have to define the three variables here by the command sims x, y, and z, semicolon, to input the command. What is the command? I'm integrating, but I have three integration. After any command, or you call it a function, you have to open bracket. So I have 1, 2, 3. So by the end, I have to close the first one, second one, third one. Okay, my function I said is 1 in exercise 10. So my function is 1. Then I'm integrating with respect to z. So comma z. What is the lower bound? 0. What is the upper bound? 3 minus 3 star x. I cannot write 3x. I have to write 3 star x minus y. Okay. I finish the first one. I close it. Comma. I am integrating with respect to y. So I put the variable y. Comma. The lower bound of y is 0. Comma. The upper bound of y is 3 minus 3 star x. Close the second integration, comma. The third integration will be respected to x. So I write comma x. The lower bound for x is 0. The upper bound of x is 1. Close the last integral and press enter. You will get the answer. Okay. Today we will speak about triple integral in spherical coordinates, spherical and cylindrical coordinates. Okay. First, we have to define what is a spherical coordinate, what is a cylindrical coordinate. Okay. Now let's go for this graph. This is a cylinder. This is why we call it cylindrical coordinate. There is a common between a cylinder and the polar coordinate. If you have the cross section here, you have x and y. And I know there is a relation between x and y and the polar, right? R x equal to r cosine theta and y equal to r sine theta. What about z? Yes, z in Cartesian coordinate is the same as z in the cylindrical coordinates, right? So this is a relation. This first two exactly like the horizontal cross section in the polar coordinate, x equal to r cosine theta, y equal to r sine theta. And z in the Cartesian is the same z as the cylindrical. Okay. What if I would like to have theta and r the opposite side? I have as a polar tan theta equal y over x and r square equal to x square y square. What about z? As I said, z in the Cartesian is the same as z in the cylinder. Let's go for the sphere. When you have a sphere, you have exactly like a cone to go around it, the upper half, okay? and you have to go horizontally cross section, right? So in this case, to cover the whole sphere from the center, you should have two angles, one horizontally and one vertically, right? The horizontally one, exactly like the horizontal one here, is theta. But the vertical one is the new one for the sphere, which is call it phi. Okay, so I have two angles in the spherical coordinate, but I have only one angle in the cylindrical coordinate, which is the same as a polar coordinate. Okay, what is the relation between this one? Okay, yes, I have to know what is the difference between theta and phi. Phi is the new one, and remember, phi should be between 0 and pi. This is why I said your phi dealing with the upper half, right? So phi from 0 to pi, because it starts from the center to any point in the upper half. Theta is the angle from the cylindrical coordinates, as I said, right? So you have no problem with the horizontal cross section. You have theta is the same, so theta could be from 0 to 2 pi, but phi is positive from 0 to pi only. What is the relation between the spherical coordinate and the Cartesian coordinate? X equal to what? Yes, why I call it rho here? Yes, the difference between the radius of the base of the cylinder, I call it by the letter small r. But the radius of the sphere, I call it by this notation rho. X equal to the radius of the sphere, sine the vertical angle, cosine the horizontal angle. Y, rho sine phi is the same as x, but they are disagree about the horizontal one theta, exactly like here. The x dealing with the horizontal angle theta with the cosine, and y dealing with this horizontal angle theta by the sine. Exactly here, y with the sine theta and x with cosine theta. But they have the same value with respect to the vertical angle phi, sine phi, sine phi. What about the cosine phi? The cosine phi will be connected to the z. So z will be the radius of the sphere cosine the vertical angle phi. Please take a screenshot for this one. Yes, if I would like to have the radius, sorry, I write it r. This is rho, not r. Sorry, this is my mistake. This is should be rho, not r. Okay. This is rho. Okay, I have to. So this is not r. This is rho. Okay. So what is this is rho? Okay. This is rho, not r. Rho, the radius of the sphere is root square of x squared plus y squared plus z squared. Cosine the horizontal angle theta. Theta can be cosine inverse z over this one, or cosine theta will be equal. To find theta, I have theta equal cosine inverse z over the radius of the sphere. What about the vertical angle? The vertical angle phi is tan inverse y over x, similar to this one, right? Okay. So to find phi, you use the same formula as a polar coordinate, right? But to find the theta, which is corresponding to this one, you have to have it by the cosine, not by that. Okay. Please take a screenshot for this one. As I said, this is rho, not r. Okay. Please take a screenshot. Okay. Please try to solve this question, right? Find the cylindrical coordinate equation for the Cartesian one. I know this is what? This is, if I look at it in 2 dimension, it is a circle, right? With radius 1 and center 0 and 1. What is the equation of this cylinder has a center 0 and 1 and radius 1 in the cylindrical coordinate? Waiting your answer. The first one finish can share his or her answer with me, please. Okay. Zain is sharing his solution with us now. He just find x and y and expand the square. So he has r square. He got r square as a common factor, and cosine square plus sine square equal to what, Zain? Cosine square plus sine square is 1, Zain. Okay? Cosine square plus sine square for the same angle is 1. You didn't write it 1.
Okay, I'll complete it now.
Okay, thank you very much. After we see Zain Ahmed solution, let's go for the yes. As Matar said, can we expand the square before we start to substitute? Yes, you can, which is better. This is y here, x squared plus y squared. You know it is a cylindrical is equal to r squared. Okay, which is better than substituting by x equal to r cosine and y equal to r sine. And you have to take r squared as a common factor, and you will have cosine squared plus sine squared, which is 1. So you end up with r squared. So it is better to expand it before substituting, because you know in the cylindrical x squared plus y squared equal to r squared. Y is r sine theta. This is 1. So you can cancel out this one with this one, right? So yes, I can cancel 1 r from r squared with this r, right? So I will keep r here and what? Yes, look at this one. This is exactly the equation of the circle of the center 0 and 1 and has a radius 1 in the polar coordinates, right? But he's talking about the cylindrical. So you have to put z equal to what? Z equal to 0, right? Yes, because when you have a equation only with x and y in the cylindrical coordinate, it means z is equal to 0. Catch my point? Okay. Yes, here it is. Here is the shape. Okay. This is a Cartesian coordinate. If you have this shape in the 3 dimension, you have x and y, z. So you have a surface like this one. But when you are talking about this one, this is the base of this shape, right? So z equal to what? Z equal to 0 in this case. So it will start to be the base is exactly the circle with radius 1 and center 0 and 1. So this is the equation of the base, which is a circle with the center 0 and 1 and radius 1. Let's go for the spherical coordinates. Okay. Look at this one. Again, can you change this one? As Matar says before, we can expand this one, right? And we know x squared plus y squared plus z squared equal to rho, right? So yes, I can do this one. Instead of just substituting by rho equal to so and so and so, it is better to expand this one and have all of this one is just rho. This is up to you, right? After you end up with having this one as a common factor, you know cosine squared theta plus sine squared theta equal to 1. So you can cancel out one of this row with the rho square. So you still have rho. Okay, this is rho equal to cosine phi. This is a sphere of the center 0, 0, 1 and radius equal to rho in the spherical coordinates. So this is equation in the spherical coordinate is a sphere equation in the spherical coordinate, but the sphere has the center not 0 and 0 and 0. center is z only 1 and x and y are 0, right? So this point has x equal to 0 and y equal to 0 because it is in the z axis, right? So this point is 0, 0, 1. This is the center of the sphere and the radius is rho, right? Now we know the relation between the spherical and the cylindrical with the rectangular axis. Let's go for the triple integral and over cylindrical or spherical coordinates. Yes, this is the volume element in the Cartesian. This is the volume element in the polar. Remember, you have r here. This r, the r d theta, is the same as the area element in the polar coordinate. So when you multiply the area by another length, you have a volume. Because if you have the area base times the height, you will get the volume. So r d theta is the area element of the base. Multiply by the height, you will get a volume in cylindrical coordinate because I have r and theta and z. In the spherical coordinate, the volume element is rho square sine the vertical angle phi d rho d phi d theta. Okay. This is the volume element, the Cartesian. This is the volume element in the cylinder. But this, remember, this is r. You can take it outside here. And this is a volume element in the spherical coordinate, rho square sine phi d rho d phi d theta. Okay. This is the triple integral. If I'm having a triple integral over the cylindrical, so my function will be a function of r and theta and z, because this is a component of the cylindrical coordinates. Now I'll go for the spherical. If I'm going for the spherical, I have a function of rho and phi, rho, phi, and theta. This is the volume element, rho square sine phi d rho d phi d theta in the spherical coordinate. In the cylindrical coordinate, my function again is a function of r, theta, z, which are the component of the cylindrical coordinates, and dz are the r theta. Please, can you have a screenshot of this one, please? Yeah. I will give you an example about what they call it, this one. This is the moment in the xy plane, right? So the moment in xy plane is explained by triple integral. Because I have a cylindrical shape, so it is better to use a cylinder coordinates. So this is a moment in xy plane is z dr d theta. I know r is the radius of the base, so I start from 0 to the radius of the base, which is 2, yeah? And theta, because the base is a closed circle, the whole circle, so theta from 0 to 2 pi. What about z? If the base of your cylinder in the xy plane starts with the 0, so your height starts from 0 up to z, and z is explained by x squared plus y squared, which is r squared, right? Again, this is easy integration. When you integrate with respect to z, you have z squared over 2, and substituted by the upper bound minus the substitution of the lower bound. Okay. Then after you finish, you are going to integrate with respect to r, and you have r to the power 5, so it will be r to the power 6 over 6, and you have already 2 here, so it will be r to the power 6 over 12. Substitute by 2, and then minus substituting by 0, you have this one. The integration of d theta is theta from 0 to 2 pi is 2 pi. So it will be 2 pi times 16 over 3, 32 pi. This is the moment, okay, in the xy plane. Now, what is the value of m? This is the value of m, or the mass. You can have it like a volume And because the density here is given by 1, so my function is equal to 1. As I said, the mass given by the density function multiplied by the volume element, and you integrate the triple integral to have the mass. Because the density is 1, so your function here is 1. It's the same boundary of the integration, like the moment. So you have this mass is equal to 8 pi unit of mass, right? If you are looking for the centroid, so you can get the coordinate of the centroid, say the z coordinate, because you have nothing in the xy plane, because you start from above xy, positive z, right? So you have the coordinate of the centroid is 0 and 0, but you have the coordinate of z, of the centroid z, is the moment mxy over the mass. So this is the centroid. The main point of this example to show you what is the benefit of studying triple integral in the cylindrical coordinate exactly. So it is very important in physics, it's very important in engineering. Now you have another application. In this case, you are looking for the volume of this shape, right? So it is described by rho less than 1 and phi equal to pi over 3. This is a cone, right? Imagine you have a cone of ice cream or ice cream cone, right? And you would like to know the shape, the volume of the ice cream inside, right? Because the cone is a part of the sphere, so it is better to use the spherical coordinate, right? So what is the spherical coordinate? This is the area, the volume element. What is your function? I said to find the volume using the triple integral, your function is 1. Your function is what? Is 1, right? So you just only integrate the volume element, which is in the spherical coordinate, is rho square sine phi d rho d phi d theta. He give you the boundary of phi. So your boundary of phi from 0 to pi over 3, the radius, he gave you the radius less than or equal to 1. So you start from 0 to 1. Theta all the time, as I said, is exactly like the polar coordinate, because you have here, you have a sphere, so you will go from 0 to 2 pi. You integrate with respect to rho, so rho square will be rho cube over 3. The upper bound is 1, the lower bound is 0. When you substitute, you have this value. Next, you integrate with respect to sine phi. What is the integration of sine phi? Minus cosine phi. Substitute by pi over 3 and then substitute by 0. Cosine pi over 3 equal to what? Cosine pi over 3. What is a cosine pi over 3? It's half. So you have half times minus 1 over 3 will be minus 1 over 6. Minus the lower bound, cosine 0 is 1. 1 times minus 1 over 3 is minus 1 over 3. And you have already subtracting the lower value. So you have minus minus, you have plus 1 over 3. Now you integrate with respect to theta. All of this one is constant, right? Which is 1 over 6. The integration of d theta is theta. Theta equal to 2 pi minus 0. So you have 2 pi. So this is the volume of the ice cream cone. Catch the point? So I got the centroid after getting the mass and the moment and the mass, and now I got the volume. Again, to find the volume, your function must be 1. Your function here is density function, and he gave it to you if you consider the density function is equal to 1, so the volume will be exactly the same as the mass. I gave you all of this example to show you what is the benefit of studying triple integral. Do you know what is this notation? This is the moment of inertia. You have got the moment of inertia in physics, right?
Yes.
So, yes, this is the moment of inertia. Okay, so I can find the moment of inertia here because I'm talking about the density is equal to 1, so my function will be 1, and this is only the volume element. So I multiply, if I got the moment of inertia about z, it will be x squared plus y squared dv. This is a volume element. I'm going to use a spherical coordinate, okay? Because I'm talking about the cone, because of the previous example. So I have to use a spherical coordinate, because the cone is a part of, I consider the cone as a part of a sphere, okay? Now it is very simple integration, because you integrate with respect to rho first, rho cube, rho 4 first, so it will be rho to the power 5 over 5, and substitute, and then I substitute sine cube. How I can substitute sine cube? I split sine cube into sine squared times sine. Sine squared, I can make it 1 minus cosine squared. So now I can integrate this one, because I have something multiplied by the derivative. So I can add 1 and substitute it. Okay. Then after I finish, I can integrate with respect to theta, and I get, this is what? This is the moment of inertia about z. Now this is your turn. I will upload this presentation, sorry. And I will leave this question, and inshallah, we'll try to give you one by one until we finish the lecture after 20 minutes or 25 minutes. So now I announce one for everyone.